Good morning, everyone. I'm Vikash. I pleasure to stand before you today and present my project Matrix Addition using Unified Memory with CUDA. This project combines the powerful parallel process using GPU and the similar process brought by the NVIDIA Unified Memory model. In this data processing require are growing exponentially. This project embracing the efficient memory management. Next, we see the objectives. The objective of this project is to perform the matrix addition using unified memory in CUDA and analyze its performance. Unified memory bridge the gap between CPU and the GPU memory space and making the program similar and more inactive. By unify by using of unified memory, we remove the need of externality data transferred. Next, we see the procedure procedure of this project. First, we want to initialize the CUDA device and return its property such as memory size and processing core. Next, we use the matrix initialization to large matrix A and B. We creating and fill with random float point number. Then the memory for this matrix was allocated using unified memory. Both the host and device could access this without manual transferring. Next, we use the kernel function. CUDA kernel was designed to compute the element sum of this matrix in parallel. Grid and blocks dimensionally were defined the optimized using of GPU. Next, performance measurement. The time taken for the computing was measured on both the host and the GPU. Next, we do the validity. The results of computing by GPU were compared to those object by the CPU to ensure the accuracy. Next, we clean up the allocated memory was free and the device was reset the concurrent. Next step, we want to see the coding. Mm, In the overall, in the overall coding, we use the in the overall coding we use the memory allocated by the CUDA malloc manager. We used to allocate the memory for A, B host reference and the G put reference. Next we implement the matrix initialization by using of initial data and floating point number to populate the matrix A and B. Next, we add the matrix addition, some matrix on host. We use this function for to add the matrix and the sum matrix X GPU. We use the matrix addition on GPU function in a 2D grid and block structure for parallel computing. Next, we do the warm up kernel to dump the kernel language in a perform to migrate the pages on GPU. Next, check result to validate the host and the GPU computing to ensure the correctness. Next, we check the error handling by using of check malloc capture to report and the error during CUDA. And finally, we do the CUDA malloc manager coding for using the clean up the CUDA device. Finally, we got the result. Okay, thank you.